Mars, a planet shrouded in myth, wonder, and unanswered questions. It is a place where science meets the imagination, a desert that was once alive with rivers and lakes. Mars isn't just a planet. It's a time capsule of the solar system's history, and perhaps a mirror of Earth's future. Mars was born alongside Earth, sculpted by the same cosmic forces that shaped our solar system. But the two worlds diverged in destiny. Mars lost its global magnetic field billions of years ago, leaving its once thick atmosphere vulnerable to the solar winds. Slowly, it transformed from a wet and warm world into the cold, barren desert we see today. Still, Mars remembers its fiery past. Olympus Mons, the largest volcano in the solar system, stands as a testament to its once turbulent geology. This behemoth rises 16 miles high, 3 times taller than Mount Everest. Nearby, the Valles Marineris Canyon system stretches over 2,500 miles, so vast it could swallow the entire United States. But these geological giants hide a quieter mystery, evidence of ancient floods, river channels, and lake beds. What happened to the water? And why did Mars become a desert while Earth thrived? Mars was once a very different place, a planet with rivers, lakes, and maybe even seas. Today, it's dry and cold, but evidence of water is still there, locked in ice at the poles and in salty streaks that appear on crater walls. Scientists believe that billions of years ago, Mars had massive floods that reshaped its surface. Could this ancient water have supported life, or is it just a memory of a time when conditions were right for life? Scientists study Mars's rocks to find clues. Certain minerals, like jarosite, only form when water is present, telling us that liquid water once flowed on the surface. Even rocks from Mars that have landed on Earth, called Martian meteorites, show signs of past water exposure. Features like the Eberswald crater delta, where a river once emptied into a lake, and inverted landforms where water eroded the ground in strange ways, show that water shaped Mars's landscape in the past. Today, traces of water still exist. The Phoenix lander found water ice near Mars's poles, and the Curiosity rover discovered minerals that had been altered by water. The Perseverance rover, currently exploring Jezero crater, is studying an ancient lakebed and searching for any signs that life may have once existed there. It's also looking for water beneath the surface, which could be a crucial resource for future missions to Mars. Mars may seem like a barren, lifeless world, but in reality, it's anything but still. It is constantly changing, shaped by forces that we're only beginning to understand. Dust storms, the largest and most powerful in the solar system, can sweep across the entire planet, lasting for weeks at a time and drastically reshaping the surface. These storms stir up the planet's dusty red surface, causing dramatic shifts in its albedo, the way Mars reflects sunlight, by as much as 10%. This not only alters the planet's appearance but also affects its climate, changing how heat is absorbed and redistributed across the globe. During the cold Martian winters, something truly strange happens. Carbon dioxide from the atmosphere freezes out, forming vast sheets of dry ice that cover large portions of the landscape. This freezing and thawing process adds to the dynamic nature of the Martian surface, creating a cycle of constant change. At the same time, the planet's surface is eroded by a combination of dust devils, which are like miniature whirlwinds, and steady winds that carve through the surface. These winds leave behind dark, irregular streaks, especially in Mars's mid to high latitudes. In the southern regions, massive sand dunes shift and evolve, causing the landscape to grow darker and lighter over time. All of these processes, known as aeolian erosion, reshape Mars in subtle but significant ways, constantly altering the surface as dust and sand are deposited and stripped away. Though these changes don't follow a regular annual pattern, they occur in cycles, making Mars a constantly evolving world. Beneath this shifting surface, Mars is not as quiet as it may seem. Data from NASA's InSight lander shows that the planet experiences quakes, Martian versions of earthquakes, that suggest Mars has a restless interior. The lander's measurements indicate that beneath Mars's rocky outer layers, a molten core may still be at work, hinting at potential volcanic activity deep within the planet. Could these underground chambers hold secrets, perhaps even life, protected from the harsh conditions above? As we explore deeper, the hunt for life beneath the surface is only just beginning. Mars is not a still world. It's a planet of constant change, full of mysteries that we are just beginning to uncover. Mars is no longer just the realm of robotic probes. It is humanity's next frontier. Plans for crewed missions are already in motion, with NASA, private companies like SpaceX targeting the 2030s for the first human landing. The journey will be long, 140 million miles, and astronauts will face immense challenges: cosmic radiation, extended isolation, and the harsh Martian environment. Yet the potential of Mars is unmatched. The planet presents a unique opportunity for humanity to push the boundaries of survival and innovation. To live on Mars, we'll need to develop advanced technologies to overcome its harsh conditions. This includes radiation shielding to protect astronauts from harmful solar radiation, life support systems to provide oxygen, food, and waste management in the thin Martian atmosphere, and water extraction methods to pull water from the planet's ice or briny underground reserves. Additionally, new habitat designs will be crucial for ensuring astronaut safety and comfort. Solutions like inflatable modules, which can be quickly deployed, and 3D printed structures made from Martian regolith, the planet's surface material, will help provide shelter and insulation against extreme temperature swings and the harsh radiation environment. These technologies not only pave the way for human life on Mars, but also offer potential solutions for challenges here on Earth. As humanity pushes deeper into the cosmos, Mars could serve as a proving ground for the technologies that will allow us to become a multi-planetary species. Terraforming Mars, turning the planet into a more Earth-like world, is a distant dream, but it's not outside the realm of possibility. By releasing greenhouse gases, warming the atmosphere, and introducing water, Mars might one day support human life without artificial habitats. But Mars offers us more than just the potential for human habitation. The ultimate mystery it presents is the question of life itself. Did life ever exist on Mars? Could it have been microbial life that flourished in the planet's ancient oceans and lakes? If Mars holds the answer, it could mean that life is not an earthly anomaly, but a cosmic inevitability, waiting to bloom wherever the right conditions exist. Mars is not only a destination for exploration, but a mirror for our own planet's future. How did Mars go from a wet, habitable world to a dry, frozen desert? Could Earth face the same fate? And what can we learn from Mars's history to ensure the long-term habitability of our own planet? As we look to the stars, Mars stands as a reminder of both the fragility and resilience of planets. The answers it holds about the past and the possibility of life will guide our exploration of the cosmos for generations to come. Thanks for watching, and I hope you learned something new today. If you liked the video, please like and subscribe.